So today we're going to be doing the 2010 AP Calculus AP free response question. This is question number 2, and it says, a zoo sponsored a one-day contest to name a new baby elephant. Zoo visitors deposited entries in a special box between noon, t equals 0, and 8 p.m., t equals 8. The number of entries in the box t hours after noon is modeled by a differentiable function e for 0 is less than or equal to 10, less than or equal to 8. Values of e of t and hundreds of entries at various times t are shown in the table above. So as we can see, this is our table they're talking about from 0 to 8, and these are our entries. Here it says, use the data in the table above to approximate the rate in hundreds of entries per hour at which entries were being deposited at time 6. Show the computations that lead to your answer. So they want to see how many entries were given at time 6. We don't have time 6, we only have 5 and 7. So 6 is in between those numbers, so we'll be using these numbers and the number of entries at those corresponding times. So for A, all we have to do is use the equation f of b minus f of a over b minus a. So 7 minus 5 over, it will be the other way around. 21 minus 13 over 7 minus 5. And I think any of us can do basic math, but in case we're not able to do that, we can input it into our graphic calculator. 21 minus 13 is equal to 8. And 7 minus 5 is equal to 2. 8 divided by 2 is 4. So that gives us 4 hundredths of entries per hour at t equals 6. So that's all we have to do for letter A. Moving on. B. Use a trapezoidal sum with the force of intervals given by the table to approximate the value of 1 over 8 from 0 to 8 e of t dt. So they give us the equation, and we have to use a trapezoidal sum. So for B, we will use this equation, 1 over 8 from 0 to 8 e of t dt to approximate 1 over 8, 0 to 8, and 1/2. We will use the intervals we have, the numbers we have here. So we need the distance from 0 to 2, which is 2, times the distance from 0 to 4, which is 4, plus distance from 5 minus 2, which is 3, 13 plus 14, which is 17, plus 7 minus 5, which is 2, times 21 plus 13, 34, plus 8 minus 7, which is 1, times 23 plus 21, which is 44. And then we close our brackets. So we input that into our equation. We could make it into a whole equation. Alpha y equals, enter, and then we could input our equation this way. Put the 1/2. So we put the 1 over 2 times the numbers we see here. So times 2 times 4 plus 3 times 17 plus 2 times 34 plus 1 times 44. And close our brackets. This gives us a total of 172 divided by 2. 171 divided by 2. So 171 divided by 2. And when we divide 171 divided by 2, we get 85.5. So 1 over well, we don't have to use this anymore since we already put in our numbers. One over 8. To 0. E of t dt is equal to 85.5. And since we already found the distance from 0 to 8, we don't have to put this anymore, but we just put it there. 85.5. And that divided by 8 will give us a total of, so what I did is, to show you guys again, I multiplied 85.5 times 1, which is 85.5 times 1, divided by 8, which gives me 10.6875. So that is equal to 10.6875, and that is our answer for B. For letter C, at 8 p.m. volunteers began to process the entries. They processed the entries at a rate modeled by the function p, where p of t equals t to the third power minus 30t squared plus 298t minus 976 hundredths of entries per hour for 8 less than or equal to t less than or equal to 12. According to the model, how many entries had not yet been processed by midnight? T of 12. So going back to this, they want to see how many entries had been processed by 12. So we have to find that number. And since we're starting from 0 to 12, we will use 23. So that will help us set up our problem for C. Is 23 minus, because we're starting at 8. As you can see, we're starting at 8, so we're going to use 23, which is our initial. So we use 23 minus the distance from 8 to 12, p of t dt equals, we will use our number 23, and we get our numbers 16, which equals 7 hundredths of entries at time 23. The way we computed this is because p of t is equal to t to the third power minus 30t squared plus 298t minus 976. I'm sorry for the messy writing. When we input this, we are gonna use 12. So in brackets, we could put 12 to the third power minus 30 times 12 squared plus 298 times 12 minus 976. And this minus, now we input 8. So 8 to the third power minus 30 times 8 squared plus 298 times 8 minus 976. So we're going to write that into our calculator. I'm sure there are many easy ways we can input this, but hopefully your teacher has taught you many of the shortcuts on how to use a calculator. If not, that will be another video another time. So as for now, we're going to input 8 to the third power minus 30 times 8 squared plus 298